Alright, here's the video guide for lesson 421, using an area model. So we were working in the beginning part of chapter 4 doing trigonometry, figuring out slope ratios that go with certain slope angles, and actually developing at the end there that you can use that tangent button on your calculator to find the slope ratio for any angle, any degree angle in a right triangle, which means we can find really the missing side of any right triangle using that tangent button. We're actually switching gears a little bit here at the end of chapter 4 and at the end of the trimester. We are going to get into probability. All right, and we've all seen probability before. You know, what is the chance that you roll a 3 on a 6-sided dice, that kind of idea. And we're going to start that off today by developing a new model using this area model here. Okay, you'll see that really what's happening is we take a square and we break the square up depending on the probability of the problem that they're giving us, and we use that model and use the multiplication into the model to solve. We'll see this. Make sure that we read. There's a lot of reading today. Make sure you read every problem clearly, and you take out everything you can out of it. There's definitions that we should know, and other important things when you read these probability problems that you need to pick up on. Okay, going into the first slide, see here we have a lot of reading. And it's just introducing the first problem here, pretty much saying we have 50% of people can bend their thumb in this weird kind of hitchhiker's thumb way, and 50% of people cannot. Well, 50% of people can roll their tongue, and 50% of people cannot. And we set it up, and this is a first picture of an area model. Okay, you have that 50% yes, 50% no, 50% yes, 50% no. You have that one bend thumb and rolled tongue. So we have the two different things, and then we have the percentages that go with them. Okay, and now we can use this to start solving. So it says, according to this table, what is the probability that a random person in the U.S. has both traits, meaning that they have the rolled tongue and the bend thumb? And really what we do here when we use the area model is we multiply into it. So we have 1/2 here, 1/2 here. Well, you multiply 1/2 times 1/2, and you get 1/4. And you can multiply into each one. So 1/2 again for yes, 1/2 for no, so that's 1/4 as well. Okay, and you can keep going and filling out the table. You can get 1/4 here, and it looks like they would all be 1/4 because they're all 1/2 times 1/2. And when it says and, so roll the tongue and bend thumb, so that's a yes and a yes. And so we have 1/4, or 25% of people can do both, bend their thumb back and roll their tongue. So that's our first look at our area model. We'll go a little more in depth, a little more challenging as we go here. So now we have, what is the probability that a random person has just one of these special traits? And so that's a yes to roll tongue, but a no to bend thumb, or a yes to bend thumb and a no to roll tongue. So same chart, so it's 1/4 for each of them. And so I'm just going to put 1/4 and a dot in each, so we can say yes, 1/4 for each of them. But this time, if we're going to look at it, we need a yes and a no, and a yes and a no. So we're actually looking at this box here and this box here. And so the probability that it was one or the other. Which means what we have to do there is we have to take the probability, which is this is 1/4, and this is 1/4, and we need to add those probabilities together because we want both of them. We want both of these here. And so I got to take 1/4 plus 1/4. When you have fractions and you're adding fractions, you just have the common denominator and you add the numerator. So 1 plus 1 is 2. 4 stays because it's the common denominator, so 2/4, which reduces down to 1/2. So 50% of people are one or the other. Can bend their thumb but not roll their tongue, or can roll their tongue and not bend their thumb. All right, here we have this probability area model, just another breakdown of it. What does it look like? Okay. And this is another way we can set this up. And so what we saw here was it was all split up perfectly nice because you had 1/2 and 1/2 splitting it in half. You had 1/2 and 1/2 splitting it in half this way. They're saying, well, we could be more detailed and split it up into like 1/4 and 3/4. So 1/4 of this is like for the yes, and 3/4 of it is for the no. Okay, you don't necessarily need to break it up this way. I generally do not, but we're just saying we can, and it actually becomes more of a visual model if we do it this way. Okay, so then they want us to alter the diagram to show, okay, if we have roll tongue, 7 out of 10 people can roll their tongue. Let's make the area model look like that. And so we want to split it where we have 7/10 one and 3/10 on the other, and just do your best to split it maybe like right here. So like this is your 3 over 10, this is your 7 over 10. And then we want what is the probability that a randomly selected person can roll his tongue, his or her tongue, but not bend his or her thumb back. And so we are looking for a yes to rolling the tongue, but a no to rolling the thumb back, or bending the thumb back. And so that would be a yes to the rolled tongue, but a no here, so we're looking for that percentage there. And I said this would be 7 over 10, and this would be 3 over 10. And we're looking for yes and no. Keeping moving here, same kind of thing. We have, this is an example of how sometimes it's nice, even though 73 out of 100 is bigger than 27 out of 100, we can still use that basic generic area model, and it says it in here, I believe. But we can use that basic generic area model because really it's all about just giving us a space to multiply in. All right, and so this is similar to the first problem with the bend and the thumb, the first two problems really. And what we're going to do here is two Navajo individuals randomly selected. What's the probability that they both have A blood type? Again, you're going to multiply into each box. And this time we're looking for this box down here because we want type A and type A. Using the area model in this last slide, we want what is the probability that they have the same blood type. So that means they could either be OO or AA. And so you'd have to add these two boxes together because there's both the probability there, OO and AA. Now here, this is a challenging problem, and I recommend copying this chart onto a piece of paper because the Desmos activity, it's tougher to write in because they're kind of smaller boxes, okay? But really what it's representing is two people, and there's really 4 different blood types. So there's OABAB, there's OABAB, all right? And we want to say the probability that they're going to match, and then we have one more difficult one as well, okay? So they're saying, what is the probability that Nick and Zach have the same blood type? Well, OO, AA, BB, AB, and you would need to add all these up because those are all the probabilities that they would be the same. Now you're probably wondering, well, what do I multiply to get in here? Well, 45% is the same thing as 45 over 100. 40% is 40 over 100. 11 is 11 over 100. So you could see it as fractions, or you could even see it as decimals. Maybe you want to use 0.4. You want to use 0.11. You want to use 0.04. So you can see it as fractions, or you could see it as decimals, and we're going to try to fill out this whole chart with the probabilities. And this one, we wanted AA, or OO, AA, BB, and AB, AB, because we wanted the same blood type. Now this one's a little more challenging. So we can use the same table, so if you have it filled out on paper, you can use the same exact table, but this time we're going to be more realistic with it. All right, so we're assuming that O is a universal donor, meaning if your blood type is O, like if this is Nick and his blood type is O, he can donate to anybody. He can donate to an O, an A, a B, and an AB. Okay? Well, we also know from the previous problem that if you're O, you can donate to O. If you're A, you can donate to A. If you're B, you can donate to B. And if you're AB, you can donate to AB. The other thing is if you're an AB person, you're a universal receiver. So if you're AB, you can take O. If you're AB, you can take A. And if you're B, you can take, or if you have B, if you're AB, you can take B. And so you have kind of a chart set up here of what you can take. You can take all these ones in the diagonal. You can take here and here. And that's going to help you figure out what the probability is of the blood that's compatible for Zach. Okay? Read the problem again closely. This is not the necessarily best explanation, but I really want to see if you can get this problem figured out on your own because it is challenging, and I don't want to go through every step of it because it takes a little bit of time. If you need more help on it, additional help, make sure you reach out and ask because it's challenging, and it's a nice way for us to really have a good understanding, develop a deep understanding of this area model and probability. Okay, last thing here is that we have this spinner probability activity, and it's a little additional further guidance, and it's kind of a fun activity for us to play with and get more experience with probability. So you open this up, and it gives you kind of a breakdown of all the different types of probability, sample space, event. It just gives you a little in-depth look at that. It gives you a way that you can see probability, so you can have your total number of outcomes over your number of ways. So like this problem, you just read into it. I don't want to go over it with the time I have, but make sure we look into this because lot of good information here, but then we actually get to start experimenting a little bit. Okay? And I want you to work through this whole thing. It's self-explanatory. They lead you through it really nicely, and it'll give you a good visualization of what's happening here. If you have any questions throughout this lesson, make sure that you ask me. I'm more than happy to help. And I know that some of them I left more open-ended, and that's on purpose to see if we can do some of these challenging probability problems.